Hello, Honors Math 3. Today is Thursday, April 2nd, and I'm finishing up our sticky ball review that we started yesterday. So I was hoping that you tried numbers 8 through 13 on your own, and then you can check our solutions here. For number 8, we're asked to find the sum of the first 25 terms of an arithmetic sequence. To find the sum of an arithmetic sequence, I'm going to use the formula S sub n is equal to the number of terms divided by 2 times the first plus the last. Let's see what we know here. So to find the sum of the first 25 terms, that's the sum of the first 25 terms is 25 divided by 2 times the first, which is 18, plus the last, which if I'm adding 25 terms, that's a sub 25. I don't know a sub 25, so that's what I need to find. A sub 25 for an arithmetic sequence is the first term, 18, plus n minus 1, 25 minus 1, of those differences. I need the common difference for this arithmetic sequence. Notice it's decreasing, and it's decreasing by 7 every time, so the common difference is negative 7. So I can find that a sub 25, the 25th term, of the sequence is negative 150. Notice you have to have your calculator handy for these. Negative 150. What is that? 25 divided by 2 times 18 minus 150. I got a sum of negative 1650. So you can check. Alrighty. Lots of formula work, so I have your formulas handy. Write a formula for the nth term of a geometric sequence. To find a formula for the nth term of a geometric sequence, a sub n is always the first term times that common ratio to the n minus 1. There's not that common ratio in the first term. The common ratio starts with the next term. So there's always n minus 1 of those common ratios. Alrighty, so my formula is a sub n is equal to the first term, which is 12, times the common ratio, which I don't know, so I'm going to find that. And the common ratio is take any term divided by its previous, reduce that. Any term divided by its previous gives us that common ratio, and that ratio is 2/3. 12 times 2/3 to the n minus 1. We're just asked for a formula for that general term, and that's it. Alrighty. I left some details about our Module 7 quest on this assignment on Canvas. So please check the details of the quest so you know when and what to expect for that quest. It's a good one. I'm making it up on Canvas. Let's see. Find the 50th term of an arithmetic sequence whose 7th term is 8 and whose 16th term is 53. Find the 50th term, that's a sub 50, of an arithmetic sequence whose 7th term is 8 and whose 16th term is 53. To find the 50th term of an arithmetic sequence, I'm going to take the first term and add only 49, always one less, 49 of those common differences. Please notice in this case I don't know a sub 1 and I don't know the common difference. So I have some work to do here. I need to find a sub 1, and I need to find the common difference. If you remember, using these two terms, I can find the common difference first. So to find the common difference, what's the difference between those two terms? That's 53 minus 8 is the difference. And how many terms is that? How many of those D's, how many of those jumps would I have? That's 16 minus 7, and remember it starts to look kind of slopey. The common difference is the slope in an arithmetic sequence. What is 53 minus 8 divided by 16 minus 7, which is 9, and the common difference is 5. Okay, so I start plugging in, and the 50th term will be the first term plus 49 of those common differences. But I need to find a sub 1. To find the first term, I'm going to use the 7th term, because the 7th term will be the first term plus only 6 of those differences, which we just found is 5. So the 7th term, what was that? 8 is going to equal the first term plus 30. And my first term, comes out to be negative 22. Negative 22. Giving me a sub 50 is negative 22 plus whatever that is, and I get the 50th term to be 223. All right, see how you did on these so far? It's great practice. You see these sequences on your ACT, SAT, so it is really good practice. Anything that you're learning on your own and working through is worthwhile. So thanks for looking at some things. Let's see. Find the sum of the first 8 terms of that sequence. Find the sum of the first 8 terms of the sequence. First of all, we don't know what kind of sequence this is, so we check, is there a common difference? We're decreasing, then increasing, then decreasing, so it's not arithmetic. Is there a common ratio? What is negative 9 divided by 27? That's negative 1/3. Is that the same as 3 divided by previous, which is negative? Yeah, it is. So that gives us a common ratio of negative 1/3, and this is a geometric sequence. Okay, if you have not yet, pause and try to remember how to find the sum of a geometric sequence. The sum of a geometric sequence. Let's jot down the formula. Is the first term times, there's a ratio in there, 1 minus r to the n over 1 minus r. Let's find the sum of the first 8 terms. The sum of the first 8 terms will equal the first term, which is 27, times 1 minus negative 1/3 to the 8th, all over 1 minus negative 1/3, which is plus 1/3. Pick up your calculator. 27 times parentheses. Make sure you have parentheses around that negative ratio also. Divided by parentheses. And try plugging that into your calculator so you're prepared for that. The sum of the first 8 terms, I got 20.25. Alrighty. This is the sum of the first 8 terms, so that's a finite sum. And then we finished off this module finding infinite sums, if possible. Let's say that this is a geometric series, and we just keep adding forever and ever and ever, and try to find that sum. Remember, we couldn't always find the sum. The only time we can find the sum is if the common ratio is less than 1. Because if the common ratio is bigger than 1, you have increasing numbers, and that sum just increases, increases, increases without bound. So the only time we can find the sum of an infinite geometric series, that's important for calculus, is if the ratio is less than 1. Okay, so what was the formula for the sum of that infinite geometric series? Much simpler, a sub 1 over 1 minus r. Let's just find that r and see if we can find the sum for number 12. The ratio, excuse me, is always a term. The common ratio is always a term, 200 over 3 divided by the previous, 50 over 1. So that common ratio is 200 over 3 times 1 over 50, which is 1, 4, 4/3. In this case, 4/3 is bigger than 1. We say that this series is divergent. If that series is divergent, then there is no sum. We cannot find the sum. It's just going to keep growing and growing and growing forever, and the sum will keep growing and growing and growing to infinity. It's a divergent series. Okay, find the sum of this infinite geometric series if it exists. Well, let's hope it does. So the sum would be this. Negative 10 plus negative 4 plus negative 8 fifths plus negative 16 25ths plus forever and ever and ever and ever, and add up all of those numbers for the rest of your life. Okay? Well, let's cut to the chase and find the ratio. The ratio is any term, -4, divided by its previous, which is -10, and the common ratio between terms is 2/5. So we can find the sum of this infinite geometric series. All of these terms, think about it, are going to keep getting smaller and smaller and smaller and smaller and smaller until we're eventually basically just adding 0. And that's where my sum stops. So let's find the sum of this infinite geometric series with a simple formula. The first term over 1 minus r. First term is -10 over 1 minus that common ratio, which is 2/5. I think we can handle this. -10 over, what is that? 5/5 minus 2/5, which is 3/5. -10 times the reciprocal of the denominator, and I get a sum of -50/3. Or if you like, -16 2/3. So if I keep adding all those terms of that geometric sequence for the rest of my life, we eventually just level out and get a sum of -16 2/3. Pretty awesome. All right, thanks for working through some problems with us. This is our little sticky ball review for Module 7. You will eventually finish up the Module 7 review assignment and be ready for the Module 7 quest. Again, check the details of that in Canvas. I didn't want to misquote on our video. And good talking to all of you. I hope everything's going well in your other classes. And thanks for joining us today. Take care. Miss you.